Okay, so here we are on our second video for the section 1.3, the notes on lines. And we're going to start right off with example 6. It says find an equation of the line containing the points 2, 3, and negative 4, 5, then graph the line. So the easiest thing to do first would be to go ahead and graph the line because we have the ordered pairs for the points. So we have the point 2, 3, and then we have the point negative 4, 5. Well, unfortunately, I didn't give us enough room to do that, so forget what I said about that being really simple and easy. If I'd given us some more room over here to the left, we'd be able to plot the other point and then just go ahead and draw the line. But we still have to come up with the equation, so yeah, go ahead and make fun of me. So with this, we have 2 points, but we don't have a slope. But we do know how to calculate the slope. Remember, we looked at that in the previous set. It's y2 minus y1 over x2 minus x1. And if we label our ordered pairs, it makes the substitution really simple. So, sorry, that's y sub 2. So what I have is 5 minus 3 over negative 4 minus 2. And I get 2 over negative 6, which reduces to negative 1/3. So there's my slope is negative 1 over 3. And then with the point slope form of the line, which we've already looked at as well, y minus y1 equals m times x minus x1, we just have to substitute. Now, you can use either ordered pair that we're given. So we can use the first ordered pair or we can use the second ordered pair. Typically what I like to do is if one of the ordered pair has a 0 in it, that's the one that I'll always use. In this case, neither ordered pair has a 0. So since we've already labeled them x sub 1 and y sub 1, we'll just use the first ordered pair. And we get y minus 3 equals negative 1/3 times x minus 2. If we simplify, and then we would add 3 to both sides, and we would get y equals negative 1/3 x plus 11/3. So there's the equation of the line. But now to graph this line, what we can do, like I said earlier, I didn't give us enough room to plot the 2 points that we had, but we can take the 1 point that we can fit on our graph and use that slope of negative 1/3, and we can go down 1 and then over 3, and now we have 2 points, and we can draw our line, and there's the graph of negative 1/3 x plus 11/3. And that's our introduction for this set of notes to something that should be very familiar. That's the slope-intercept form of a line, and that will give us the y equals mx plus b. So for example 7, it says find the slope and the y-intercept of the equation 2x plus 4y equals 8. It's easier, this equation right now is in what we call standard form. We want to take it from standard form into slope-intercept form, because in slope-intercept form, I know my slope right away from looking at the equation, and I know my y-intercept by looking at the equation. So if we take the 2x plus 4y equals 8, and we'll get it into slope-intercept form, the first thing we do is subtract the 2x from both sides. And that gives us 4y is equal to negative 2x plus 8. And then I divide everything by 4, which gives me negative 1/2 x plus 2. So looking at this equation, my slope is negative 1/2, my y-intercept is positive 2. So let's mark my y-intercept on the graph, and then we can use the slope. We can go down 1 and then over 2 units, and that gives us this rough graph of the equation of that particular line. I mentioned a minute ago standard form of a line. It's also known as general form of a line. With the standard form of a line, it's always in the form of ax plus by equals c, where a, b, and c are going to be some real numbers, and a and b can't be 0. For example 8, we're using the exact same equation that we had before, the 2x plus 4y equals 8, but this time we're graphing it by finding the intercepts. And we looked at intercepts in our previous set of notes in section 1.2. So remember, to find an x-intercept, that's when y is equal to 0. So let's take our equation 2x plus 4y equals 8 and replace the y with 0 and solve this. So what we're left with is 2x is equal to 8. Divide both sides by 2 and we get x equals 4. So there's our y-intercept, or our x-intercept, I'm sorry. X-intercept of 4. Then our y-intercept is when x is equal to 0. So we take the same equation, except now we replace x with 0, and we solve for y. So now what we have is 4y equals 8. Divide both sides by 4, and we get y is equal to 2. And that's our y-intercept. And if you look up here at our slope-intercept form, our y-intercept did happen to come out to be 2. So everything does seem to be working out pretty good for us. And whoa, that's a terrible line. There's the graph of our line, which is roughly the same, given my limited drawing ability on this computer, to be the same graph we obtained in example 7. Just a different form of the line and a different way of finding the values for it. When two lines are in the same plane, so now we're going to talk about parallel perpendicular lines. When they're parallel, from geometry, you guys should remember that parallel lines never intersect. So it would stand to reason then that two parallel lines that are in the same coordinate plane that don't intersect would have the exact same slope. So if we take these two equations that we're given, so to show that two lines are parallel, we only have to show that they have the same slope. So if we take these two equations, they're both given to us in standard form. If we saw both of them and put them into slope-intercept form, we'll quickly be able to identify the slope, and then we'll know whether or not the two lines are parallel to one another. So looking at line L sub 1, which is 2x plus 3y equals 6, if we solve that we begin by subtracting 2x from both sides, so we have 3y equals negative 2x plus 6, and then we divide everything by 3, and we get y equals negative 2/3 x plus 2. We're going to follow the same steps on line L sub 2 and see if we come up with the exact same slope, hopefully a different y-intercept, because if it has the same y-intercept, these lines wouldn't be parallel, they'd actually be the exact same line. So we subtract 4x from both sides and then divide by 6, which does give us negative 2/3 x. So the y-intercept for this graph happens to be 0. The y-intercept for the first one happens to be 2. So they are different lines. They have the exact same slope, so they are parallel. And I promise to rewrite these notes much neater when I have a minute, because when I write these out while I'm doing the videos, I write really fast and it gets really sloppy, so I apologize. Example 10 says find an equation for the line that contains the point 2, negative 3 and is parallel to the line 2x plus y equals 6. So let's first start out with the line 2x plus y equals 6. We need to know the slope of that line in order to find any line that's parallel to it. So we would set this up where we get it in slope-intercept form. So we only have one step on this problem. We have to subtract 2x, and we get y equals negative 2x plus 6. So our slope is negative 2. And here we have a point. So we have a slope and a point, which means we want to use the point-slope form of a line. And we just have to substitute our values in. So y minus y sub 1 is y minus negative 3 is equal to our slope, negative 2 times x minus 2. Before I go on, what I want you guys to note is that when I wrote this out, when I did the substitution for that negative 3, I put that negative 3 in parentheses. That's a habit that I picked up because on your calculators, if you type this in your calculator, if you type anything in your calculator, let's say you did 2 minus negative 4, you definitely want to make sure that you put any kind of negative values in parentheses. It's just a good habit to get into, because if you put negative 4 squared in your calculator, the calculator will tell you it's negative 16, which is not true. Negative 4 squared is positive 16. So in your calculator, you should put in -4 in parentheses and then square it on the outside of the parentheses. That's just one of those little touchy, weird things about the calculators and how the order of operations is set up within the operating system. Anyway, so we distribute the negative and we get y plus 3 equals -2x plus 4. We subtract 3 from both sides, -2x plus 1. So there's the equation of the line that is parallel to the line 2x plus y equals 6. And now we're going to talk about our last type of line for the night. It's perpendicular lines. Perpendicular lines, if you recall from geometry, are two lines that intersect at right angles to one another. So their slopes are opposite reciprocals of one another. So we mentioned that right here in the notes, opposite reciprocal slopes. The product, if you take the two slopes of two lines and you want to test whether or not these two lines are perpendicular, you would simply multiply the two slopes together. And if their product is -1, then you know that the two lines are perpendicular. So opposite reciprocal means we change the sign. That's the opposite part. So if it's negative, it's positive. If it's positive, it's negative. And then the reciprocal part, just simply, for lack of a better term, means we flip the number. So if it's a fraction, if it's, say, 2/3, we would flip it and it would become 3/2. If it's a whole number, say 4, then we would flip that and it becomes 1/4, because 4 can be written as 4/1. With our example 11, it says find an equation of the line that contains the point 1, -2 and is perpendicular to the line x plus 3y equals 6. So just like in the previous example, we want to get our given equation in slope-intercept form. So we would subtract x from both sides. And then we would divide everything by 3. Excuse me. So our line is equivalent to y equals -1/3 x plus 2. Our slope is -1/3. But since we are looking for the perpendicular slope, we would take our given slope of -1/3 and we're going to do the opposite, which means we change the sign. So now it's +1/3. And then we take the reciprocal of that, which is 3. So the opposite reciprocal of -1/3 is +3. So the slope of our perpendicular line is going to be 3. And then again we go back to the point slope form and substitute in our values. We get y minus -2 equals 3 times x minus 1. That gives us y plus 2 is equal to 3x minus 3. Subtract the 2. And this line, y equals 3x minus 5, is going to be perpendicular to our given line of x plus 3y equals 6. So this was a low down, quick and dirty review of lines. The first 3 sets of notes have been reviews or refreshers, or maybe you may have just forgotten all of it completely and you've looked at some of these videos and you said, wait, what? I don't remember any of this. And that's fine. This class is not designed to frustrate you or to make you fail. We're going to get through everything together just fine. If I say that you should have probably seen something already, there's a possibility, hopefully slim possibility, that maybe you haven't. But these first 3 sets of notes hopefully have been a refresher for most of you. If you don't recall any of it, don't worry about it. Just ask me in class. Let's go over it and we will work through these problems together. I hope you guys have had a great evening, and I will see you in the morning.